Hi everyone. In this episode, we are going to clean up our project and introduce Pinia Store, the state management system for Nuxt. You will see how Pinia can greatly simplify communication between components and eliminate the need to pass props or emit events up and down the component tree. We'll carefully go through the entire process of moving logic from components into the store and see how it improves and clarity and simplicity of our code. So let's get started. Alright, just like I promised, in this episode I will show you how to give our application a little boost using Pinia storage. So let's fire up the project, and quick note before we dive in. If you want to follow along with me, you can clone the repo, the link is in the description, and switch to the feature S01E09-start branch. That's exactly where the app is at the beginning of this episode, so you will be all set. Then step by step you can move through the tutorial together with me. As you probably remember, we have got our parent and child components here. When we click the spin button with the child's name, the child starts spinning. A child can also say it's hungry, and then the parents prepare some food for it. Nothing new here, we have already covered all of that in the previous episodes, and we are still building on the same app. Now we are adding some new, another component. Let's call it teacher. This teacher component will do two things. First, it will show a list of the kids that are currently spinning, and second, it will let us stop all the kids from spinning with a single button, no matter which parent components they belong to. Now let's add this component to our main page view. To make it stand out a bit, I will change its background color. Let's go with BG Green 400. For now, the kids list is static, but in just a moment we will make it more dynamic. We will make it dynamic, not more dynamic. First, I will show you how we can handle these requirements in the traditional way without using Pinia storage. The idea is simple. Inside the teacher, we will display a list of all kids that are currently spinning. Plus, we will have a button that stops them all at once. Alright, let's start with the classic approach. So here is our component. When we click the spin button with a child's name, the child starts spinning. Now let us see how this affects our variable. We will focus only on P2 kids to keep the view clean. As you can see, clicking spin tom or spin crease does not change anything in the values of the P2 kids array. This happens because it's simply a regular constant. View uses it to render the interface and the children's names in the parent component, but it does not observe changes inside that array. Okay, let's now change the constant P2 kids into a ref. And now, as you can see, when we click the spin tom or spin crease buttons, the values in the array starts to change, because view is now observing this array. As you remember from the previous episode, I talked about copying values and using them in components that receive them through props. In our case, that was props kids, which we copied into a kids variable. Here, however, we are not copying the actual values, but the references. That is why clicking the button works and directly affects our P2kids variable. In other words, clicking inside the parent component modifies P2kids, which was passed through props and at the beginning copied as a shallow copy, meaning a copy of references. If we want to completely cut off from the references in props and create a brand new dedicated kids object inside the component, we just need to copy the values into that variable in the way that produces new objects, independent from the ones in props. In that case, clicking spin tom or spin crease will no longer change the values in the array passed through props. As a side note, let me show you how to properly copy values when you need a completely separate object. Earlier, I showed you the built-in JSON parse JSON stringify trick. It works, but it's not ideal because it strips types and may simplify the data. A much better option is the Lodash library, which can copy objects while keeping their types. To use it, you first need to install it, and then you can call the clone deep function, which creates a new structure without any references to the props. As you can see, I ran into a TypeScript error related to the import. It turned out the problem was simply an incorrect import of the clone deep function. After fixing that, everything worked correctly, and Lodash successfully copied the object into the kids variable, fully detached from the props. Just like in the previous example, this guarantees that we are not modifying the values passed in through props. As I mentioned in the previous episode, how you choose the copy values and how you use them depends entirely on the effect you want to achieve in your components. In our case, we actually want the values to preserve their references so that when we update them in the parent component, the changes are immediately reflected in the props. This allows us to later pass the updated data into the teacher component. That is why we are returning to the earlier version of the code. You can see that passing values between components in the traditional way without any storage can be a bit cumbersome and may cause issues. Of course, in simpler cases, it makes sense and can be useful, but you do not always need to bring in a heavy tool like Pinia storage or any other storage. The key takeaway is to clearly understand the differences, the rules, the limitations, and the possibilities of both approaches, so you can always choose the best solution for your project. Just like with the p2kids variable, I am now changing p1kids into a ref so that it can be modified and view can observe and react to changes. I'm also removing some unnecessary parts of the code to keep things clean. At this point, if we make any changes, they will be reflected in both p1kids and p2kids. This way, we can easily use this data and pass it to another components. Let's break this down into steps so we do not lose track of anything. Step 1. We need to pass the children's names to the teacher component. Step 2. Inside the teacher component, we will display the names of the children that are currently spinning. And step 3. In the same component, we will add a button that stops all the children from spinning when clicked. Alright, step 1. Passing the children's names to the teacher component. There are of course many ways to do this. One of them, although completely not recommended, is the approach I am about to show you. Passing both p1kids and p2kids directly into teacher component and handling them there by checking which child is currently spinning. This method is very inflexible because if we add more groups of children, we would have to constantly expand the teacher component with additional parameters like px_kids. A much better solution in this case is to create a computed variable that automatically updates and returns the names of the children that are currently spinning. As you can see, this computed simply merges the children's arrays, then filters the records where is spinning is set to true, and returns an array containing only the names of those children. The AI built into my IDE also recognizes this and suggests exactly the same computed-based approach in the teacher component, and we add a props property called spinning kids, which will receive the values returned from the computed function, and we will be able to use them directly inside the component. In the template section of the teacher component, we will display the list of children's names using the loop that iterates over the values passed through the spinning kids prop. There is one small thing to note here. As you can see, the AI suggested using the child's names as the key in the loop. However, logically speaking, there might be a case where two different children have the same name. And in that case, the keys would not be unique. It would still technically work, but to be safe and confident that everything functions correctly, we can generate the key dynamically by combining the child's names with its index. This way, each key in the list is guaranteed to be unique. Alright, let's see if it works. After restarting the server, when we click the button and of course not I'm hungry but spin along with the child's name, we can see that the children's names appear in the teacher component. All the spinning children are displayed on the list, so our component is working correctly. However, as I mentioned earlier, adding each group of children as a separate parameters in the teacher component is not very flexible. I proposed a solution based on the computed property, but it also has some limitations. If we add more children in the future, we would have to manually include their arrays in the computed function so that everything continues to work. To be completely fair, let's make a small change that will allow us to add any number of children, and the computed property will handle it automatically. This way our solution will be fully flexible and independent of how many children we have in the application. Alright, so we want to add the P1 kids and P2 kids variables into a single array from which they will be retrieved and generated. Let's make a quick modification. We will start with the types. As you can see, we already have the child type that defines the children. Now let's create a more global type called family, which will represent the entire family. I will also rename the file to family.ts in the types directory so that it better reflects its contents. This is where we will define the family type. So now we are adding the family type. As you can see, the AI immediately suggests the structure for it, almost correct, but our family type will look a bit different. It will contain an ID, a kids array of type child, and the parents' names father and mother. Now let's move to the index.view file in the pages directory and make some updates to reflect the changes we made to the types. First we import the family type and then we create a variable called families, which will be an array of family objects. In the first family we set the father's name, the mother's name, and copy of the children that were previously in the P1 kids array into the children key. We then do the same for the second family. As you can see, the AI keeps suggesting bits of code. It does not always get it right, but it is clearly improving week by week and is now capable of generating quite a lot of useful code. You will see in a moment that some of these suggestions look rather interesting. In the second family, the AI suggests the father's name Mike. What a coincidence that happens to be my name. I hope the AI is not spying on us that closely yet. For the mother, it suggests Mary, and thankfully that is not my wife's name, so we are safe. We assign the children to this family as well, and just like that, we have a fully prepared families variable ready to use. We can now remove the old variables with the children P1 kids and P2 kids. As you can see, an error immediately appears, but we will fix it in a moment. First, let's clean things up a bit. In the previous version, we added the parent component. Now we will make a few adjustments. First, we will create a loop that iterates over the objects in the families array. We will use the v for family in families directive for that. Next, we will rename the component because it's no longer just a single parent but an entire family. To make it clear and better align it with what the file contains, we will name this component family. We will also rename the file in the components directory. Visual Studio Code immediately detects the change and asks whether to update the imports. It's worth confirming this. As we know, in Nuxt we rarely need to worry about imports, but if we were working in a plain view, the editor would automatically fix the paths for us with a single click, which is very convenient. Let's now modify our component so that everything starts working correctly. At this point, we no longer pass only kids as a props. Instead, we are passing the entire family object, which represents the whole family, and we will name the prop accordingly. Inside the component, the reactive variable that was previously defined as kids will now be replaced with family, so that we can refer to the entire structure directly. The previous shallow copy of the props will be also updated. For now, just to keep things clear and easy to follow, I'm going to comment out some parts of the code that are not currently in use. They make the file look a bit cluttered, and I do not want the view to be confusing, especially for those of you following along. I will leave the small to-do comment there so that we will remember to come back to this logic a bit later in the episode. In the template section, I'm doing the same thing. I commented out the part of the code that was generating additional information through the computed property called cooking for, which I also disabled for now. This makes the template much cleaner and easier to read, allowing us to focus only on the essential parts of the component while we adapt it to the new data structure. So, after commenting out the unused code and saving the file, I can see that there is still an error showing up in the editor. Let's take a closer look at what is causing it. It's probably something simple, like a reference to a variable or property that no longer exists after our refactor. So let's fix it. I left the old assignment where a new array was being created, but now we have the full family object, so we assign it directly to the family variable. This way the component works directly with the complete family object. Alright, let's close the unnecessary files and go back to index.view. As you can see, I often close files that I am not using. I do this to keep my IDE clean and organized. When you have many files open across multiple Visual Studio Code windows, especially while working on both backend and frontend code, this habit becomes really helpful. In the family component, we add the missing props family, and now the error related to this component is gone. As you can see, the page is displayed again, and our application with the parent components is working correctly. Let's quickly check if everything is working as it should. Changing a child's name is immediately reflected in our application, so it looks like everything is working correctly. We can now continue cleaning up our code. Let's start by fixing our computed variable called spinning kids, which, as you remember, returns the list of names of the children that are currently spinning. As you can see, I used a bit of help from the AI here. I just updated the comment above this variable to make it fit better with the current structure of the family object. The AI immediately suggested the necessary filtering changes to make everything work correctly, and this way you can easily speed up your work. After restarting the server, as you can see, everything working correctly, so we can move on. What next? I think we no longer need to keep the variable with the family data directly in the code. We can move it to an external file so that our component and page contain only the logic that operates on the data, but not the data itself. So let's copy the families variable and move it to the data/families.ts file. Then we will export this variable and check if everything still works as expected. There is still a small error here. When we hover over it, the IDE shows what is wrong. We need to fix the variable we are exporting. It is no longer a reference, so we should not define it as a ref. Instead, we export the raw data. So let's remove the ref, assign the correct type family in the right way, so the TypeScript knows how to handle these values, and then export the families variable properly. Additionally, we also need to fix the import in the index.view file. We import the families variable from the data/families and using curly braces, like you see in the video. Note that we do not include the .ts extension in the import path, since TypeScript automatically recognizes it. After importing, we assign our variable to the one that Vue is observing, which is the ref called families. However, we immediately run into a naming conflict because there are too many families variables in the same file. We need to fix this. The simplest solution is to rename the exported family data to families data. After updating the variable names, imports the ref assignment and adding the proper types, everything works correctly. TypeScript no longer reports any errors. Hooray! Let's restart the server and check if everything is working. As you can see, the application is running correctly. When we click the button, the children start spinning, so it looks like everything is fine. However, notice that in the second family component, the children have lost their color. The skin color value is no longer being applied. So let's take a look at what is happening here. In fact, this is an interesting case that we will discuss in more detail. So honestly, I'm quite happy that this bug appeared, because it gives us a chance to see something that sometimes happens in real projects. Let's trace this step by step. In the data used to create the family components, the second entry sets skin color to BG green 800 for each child. In the family component, this value is passed along, so the variable reaches the child component. Let's check the child component. Everything suggests that the color should be rendered. To be sure, let's verify whether the class name bggreen800 actually arrives, for example by rendering it under the child's name, or whether it is replaced by default value defined in the props. It looks correct, and the proper class name is being passed to the component. So why are we not seeing the expected child color? Moreover, if we inspect the generated code in the browser, we can still see that the child's object contains the correct class name and the corresponding color value. This means we can be sure that it's not a programming error and not an issue with Vue.js. The missing color must be caused by something else. Honestly, at this point there are not many possibilities left. Since it's neither the Vue issue nor a coding problem, it's quite likely that the cause is related to Tailwind. In a Tailwind documentation, we can find that the content key in the configuration file defines the file sources that the framework scans for Tailwind class names. The mechanism works in such a way that when the project is built or run in development mode, Tailwind analyzes the specified files, including templates and any other files that may contain class names, and adds the detected classes to the final style sheet. This ensures that the application includes only the minimal set of classes actually in use, instead of the entire Tailwind library, which is huge. In our case, the file containing the data about the children and their skin colors, data/families.ts, is indeed part of the project, but it is not within Nuxt standard application structure. As a result, Tailwind does not scan this file and therefore does not detect the class names defined there. That is why the bggreen800 class is not included in the generated CSS, and the children's color is not displayed. At this point, we do not yet have a Tailwind configuration file, so Tailwind is currently running with its default settings. Let's create a tailwind.config.ts file in the root application directory, following to the documentation, and add a content section. This section defines which directories and files should be scanned for class names. As you can see, the configuration includes the standard directories such as components, layouts, and pages, which are the usual places where Tailwind classes appear. I'm also adding our custom data directory, since it may contain JavaScript or TypeScript files with class names that Tailwind needs to include. Alright, let's see if our changes and fixes worked. After restarting the server, as you can see, the children have regained their skin color and are green again. Everything is working correctly. Tailwind is now properly configured, including the additional directory with the family data, and it now scans those files as well to find the class names that should be included in the style sheet. Everything looks good. Notice how much simpler our code has become. At this point, both the component and the page contain only what is actually responsible for generating the content. We have removed the unnecessary parts, and the code is now much clearer. Alright, after this short digression about Tailwind, let's move on to the next step. The teacher component that displays the names of the spinning kids. The good news is that this functionality is already complete. Our spinning kids variable returns the list of the children that are currently spinning. A moment ago the AI helped us fix this code, and now we are passing the data to the teacher component. Now I will tidy up the code a bit so that all the requirements we are implementing are listed in one place, and I will mark the steps that have already been completed. Since we have saved some time by already completing one of the requirements, I like to make a small change to our code. The goal is to make it a bit more realistic and closer to how things would work in the real world, while also helping to demonstrate the concept and behavior of Pinia storage, which we are about to implement. This will also show how much it can simplify our code. Right now, the situation where the teacher component is on the same level as family is not very realistic. In a real life, teachers belong to schools and work within classes, so we are going to nest the teacher component inside the new school component. As you can see, I am starting by creating the school component, where we will place the other elements and components. Every school, of course, has different classes, so we will also create a class component where we will display the teachers of a given class. For now, let's simply create the class component that will display the name of the class. We will pass the class name as a prop to the class component. As you can see, there is nothing new here. We have already discussed all of this before, so it should look familiar to you. In a school component, let's add a simple variable called classes that contains a list of class names. I am leaving it directly in the code for now and not moving it to an external file, since this is only a temporary solution and the variable doesn't make up much space. In the template section, we will display the list of classes and pass the class name prop so that the correct class name is shown. Alright, we now have all the components ready, so let's put them together and see how everything works. In the index.view file, I'm adding the school component and making a few small adjustments to its appearance. As you can see, the AI keeps suggesting different improvements. Sometimes these suggestions can clutter the view a bit or miss my actual intent, but overall they are definitely useful and can make programming a lot easier. I will make one more small change in the template section. We won't display the classes as a list anymore. since it's not worth spending time formatting it. Instead, let's use a simple flexbox layout. We will create the main div with the tailwind flex class and add a gap 2 for spacing. Inside that element, we will iterate over the class names, creating separate divs for each one. We will also give each of them a fixed width to make the layout cleaner. This way everything will be easier to see and will better represent the structure of our components. Finally, let's move the teacher component into the class component so that each class displays its own teacher, which is our teacher component. At the same time, let's remove it from the index.view file since it's no longer needed here. Okay, it looks like everything is ready. Now we can move on to the next step, which is passing information to the teacher component about the children that are currently spinning. First, we need to pass the information about the spinning children from the spinning kids variable to the school component. This will allow us to forward the data further down to the components nested inside it. Next, we need to pass the same parameter that we already have in the school command further down to the class component. From there, we pass it again to the teacher component. As you can see in the video, there is a small mistake here that I will fix in a moment. Still, the main idea of how parameter passing works is probably already becoming clear to you, and you can see how it functions in components that depend on each other and are nested one inside another one. The mistake was that in the school component I did not use the class component, which displays the teacher and the class name. Instead, I inserted a plain div with the class name. We need to fix this by replacing the div with class component. Now let's check whether everything works after the change and whether adding the class component inside school shows the names of the children that are currently spinning. Now everything is working correctly. It may not be perfect since each class currently shows the teacher with a list of all spinning children. We could theoretically add filtering so that each teacher only sees the children from their own class, but there is no need to make things more complicated right now. In a moment, we will move on to implementing Pinia storage, and you will see how easily we can replace our current code, which, as you can tell, is already quite complex and can lead to errors or make debugging more difficult when something doesn't work as expected. At the moment, the information about which children are spinning is first passed to the school component. Then school propagates it further down to each class component, and finally in the third step the class passes it to the teacher component. Only at this stage does the teacher use the data to display the list of spinning children. Now let's see how with this setup and these components we can implement our third requirement, which is to give each teacher a button that stops all the spinning children. Alright, let's do this in a fairly traditional way. I'll admit it's been a while since I've implemented something like this manually, but for the purpose of this tutorial, let's go with it. In a teacher component, as you can see, I am creating a stop all kids button using the layout suggested by the AI. Additionally, we need to define the emission of the stop all kids event in this component, which we do using define emits. There are two ways to do this. We can define it as an object with an event definitions, as the AI suggestion shows, or we can use a simpler approach by declaring an array of strings that represent the names of emitted events. I'm going with the simpler version and defining define emits as an array of strings, in our case one string. In the button click action, that is in the @click event, we define the emission of the previously declared event. In practice, we simply call emit and pass in the name of the string we defined earlier. This allows the teacher component to send the signal outward to the components it is nested within. In the class component, which contains the teacher component, we need to repeat the same operation and send our signal one level higher. As you can see, I am copying the define emit definition into the class component, and in the teacher component that sits inside it, I am doing the same thing in the stop all kids action, emitting the event upward to the parent component. In our case, the parent component is school, so we emit the stop all kids event there. And we do exactly the same thing in the school component, sending our stop all kids signal one level higher. As you can see, writing code like this and managing the emission of events and data flow between components in both directions can be quite cumbersome. It requires a lot of code, and more importantly, such a setup becomes very difficult to debug when something goes wrong. However, for now though, let's get back to our tutorial and implement the final change in the index.view file. And our final solution is in the index.view file, where on the stop all kids event we call a function with the same name. This function performs a very simple operation. For each parent and each child, it sets the isSpinning parameter to false. Okay, let's save the file and check if everything works as expected. Let's spin a few kids, and as you can see, pressing the stop all kids button on any teacher stops all the children. None of them are spinning anymore. This demonstrates the full path of how the information about spinning children flows downward to the teacher component, and then the same path in reverse when the teacher component emits a signal to stop all the kids. As I mentioned earlier, this approach is quite complicated. It is difficult to analyze, and while in this simple example we only have a few components and a single event being passed around, in larger projects this kind of code quickly becomes hard to debug. And even more hard to understand. That's exactly why state management solutions were created to make handling application state cleaner and more manageable. One of those solutions is Pinia Storage, which we are about to implement. You will see how much easier it makes our code and how it simplifies state management in the application. Alright, now that we have seen how complex our code can become, let me show you how we can simplify it. I am updating the description of our requirements so it's clear what we are working on, and we will move on to implementing the same functionality, but this time using Pinia Storage. Pinia Storage is a solution that allows us to manage the state of the entire application and all related variables in one central place. This means that components using data stored in Pinia Storage automatically react to changes in that data. There is no need to manually pass information between components, which makes the code much simpler and far easier to read. On the pinia.vue.js.org website, you can find detailed information about what Pinia Storage is and how to work with it. It is a comprehensive and valuable resource. I will show you a practical example of how to use Pinia Storage, which I hope will make it easier for you to understand how it works. In the documentation, you will see installation instructions for Pinia Storage using the yarn command. However, I am skipping that step and removing already installed Pinia Storage because we are working in a Nuxt application, so let's take a look at how to add Pinia Storage in a Nuxt environment. On the Nuxt.com website, in the modules section, you can find information about Pinia Storage and how to add it into a Nuxt application. It's really simple. As you can see, all we need to do is add the Pinia package and the Pinia/Nuxt module. After short installation, we can add the module to the list of modules used by the application in the nuxt.config.ts configuration file. Once this is in place, we can move on to creating our first storage. Returning to the pinia.vue.js.org website, in the documentation section, we can find information on how to create our first storage. Pinia Storage supports both approaches to working with Vue.js, the traditional and older options API, which is no longer recommended, and the modern and preferred composition API. We will of course use the composition API option. I'm copying the example code for creating a storage to the clipboard and I will use it in a moment. In the store directory, in the file named usefamilystore.ts, I paste the copied code and adjust it to fit our application. We create a Pinia storage using the define store function imported from the Pinia library. The first argument is the store identifier. It must be unique within the entire application, as Pinia uses it to recognize and manage individual stores. The second argument is the setup function, where we define our variables, state values, and functions that we want to return and use across the application. As you can see, defining a store in Pinia with the composition API is quite simple and very straightforward. Let's start building our store. We'll begin with the family data. As you may remember, in the index.vue file, we imported external data from datafamilies.ts file. We'll do exactly the same thing here in our Pinia store. We import the data from the same file and assign it to the families variable, just as we did before in index.vue. Finally, we add the families variable to the return section of our store so that it's exported and available for use in other components across the application. In the index.vue file, we can now remove the previous imports, since we are using our store, which already contains all the information about the families. As you can see, I import the store and define the families variable, which is reactive. That's why I use the store2refs function from the Pinia library. If we declare this variable without store2refs, it would lose its reactivity and wouldn't respond to state changes. So to keep the variable reactive, we use store2refs from Pinia. Okay, what's next? Now we move the functions we previously defined in index.vue into our Pinia store, since that's where they should live and be used. Both the computed variable spinning keys and the stop all keys function belong in the store, not inside the component, or in our case in the page. We no longer need them in the index.vue file, and in fact we shouldn't keep them there, because all application state management logic should reside in the store. After moving them, don't forget to export both the spinning keys computed property and the stop all keys function, so they can be accessed from the other parts of the application. I see that the index.vue file is reporting an error. This happens because the variables and functions that were previously used here have been moved to the store. Technically, we could re-import them, but in our case, there is no need to do that. In the school component, we no longer need to pass the spinning keys property, since we are not propagating the data anymore. We also don't need the stop all keys function, as its logic now lives inside the Pinia store. Everything is now handled at the storage level, not in the index.vue file. As you can see, after removing the stop all keys function from the school component and the spinning keys variable, which we no longer need to pass, Visual Studio Code slightly grays them out in the code. This is the editor's way of indicating that these items are unused and can safely be removed. And it is a helpful reminder to avoid unnecessary imports and keep the code clean. So, Following Visual Studio Code suggestion, I remove the unused stop all kids function and the spinning kids variable since we no longer need them in the school component or in the index.view file. Let's move on. In the school component, we no longer need to define emits or use define props, since this component no longer needs to receive or send any data. Until now, it served as a middle layer for passing information up and down the component hierarchy. Now, this is no longer necessary because school is only responsible for generating the individual classes. As you can see, this makes the application code much simpler and easier to read. We simplify the class component in the same way. Here we no longer need define emits since nothing is being emitted from this level. In define props we keep only one parameter, class name, which is the only value handled by our class component. Everything else can safely be removed from the code. Now let's move on to the teacher component where we will be making the most changes. First, I import our store that we created a moment ago. Use family store from the store use family store file. Previously, in the button definition, we had an action that stopped all the spinning children when clicked. Now we do the same thing, but using the function from our store. In the template section, within the add click action, I call the stop all kids function from our store. As you can see in the video, there is a small error in the function name. It's just a typo, so I fix it to correctly reference the stop all kids function defined in use family store. Earlier, the button emitted an event that triggered the stop action, but now it directly calls the function from the store. I can still see an error in the class component file. The issue is that we no longer pass spinning kids to the teacher component. That is correct because teacher now reads spinning kids directly from the store, so I remove define props in the teacher and fetch the spinning kids variable using store2refs from our use family store. Okay, let's take a quick look to make sure there are no errors in any of the files. Everything seems fine, there are no red highlights or error indicators. Let's also close the unnecessary files that were opened along the way to keep our workspace tidy. I'd like to go through each file and component one by one so we can clearly see what's happening and what changes we have made. Let's start with the index.view file. As you can see, we import the store we created earlier and define a single reactive variable families using store2refs. Then in the template section, we generate the family components by iterating through the objects contained in the families array. Next, we have the school component, which does one simple thing. It generates classes based on the classes array defined in its code. One straightforward purpose for this component. The next component is class, simplified to the maximum. As you can see, its only purpose is to render a class that contains the teacher component, and that's it. A very simple and straightforward component. And finally, we have the teacher component, which is also simplified. Here we simply use the stop all kids function and the computed value spinning kids, both defined in our store. As you can see, everything is very straightforward, and thanks to using Pinia Store, we no longer have to deal with passing props or emitting events up and down between components. Now let's check if everything works as expected. As you can see in the video, and probably also on your own computers if you are following along locally, everything is working correctly. The spinning feature works as expected. The names of the spinning children are properly displayed within the respective classes. The teacher can also stop all the spinning children, and all the events and variables are now managed through the Pinia Store. And that's it for today. In this episode, we learned how to use Pinia Store in Nuxt, how to move application logic into a central state management layer, and how this helps make our code cleaner and more organized. Now, all our data events and functions are managed in one place, making the app more transparent and easier to maintain. In the next episode, we'll move on to the backend and build an API that returns information about families and their children. So have a great day and see you soon.